Hey everybody, and welcome back to Jim's Garage. In this video we're going to be checking out Twingate, and thanks to Twingate for sponsoring this video. Now it's important to stress that Twingate is not a VPN. Twingate is a secure way to access your internal services. It's based upon zero trust network architecture, it removes all of the requirements for dedicated hardware, there's no need to open any ports or things like that, and it gives you fine granular control over who can access what. In this video, I'll be showing you how to start this. We'll go through the entire sign-up process. I'll talk to you about what networks are, what resources are, and what connectors are. I'll be deploying some of those in my own infrastructure, and I'll also be testing that out with my mobile devices over cellular networks so you can see how this would perform in the wild. I'll also give a full overview of the administration console because there's a load of cool security concepts in there, lots of different things that we can put in place to limit access to only the users we need, to only the resources we need. So let's dive straight into it. So whilst this isn't a VPN, it does incorporate lots of technologies you would find within a VPN and comes with all the bells and whistles regarding cryptography, security, private transport, etc. So if you have a look at their website quickly, you can see a ton of testimonials for some really big organizations. So it's great to see how mature this is and how widely adopted it is. And I've even seen this in the enterprise space through some of my colleagues as well. Now, do note that this is not a self-hosted solution. This is a managed service. So you will have to be dialing into Tailgate's website for that administrative console. Now, before you go to town in the comments about how introducing a third party is an unnecessary risk and you should just be using a VPN to do this, you've got to understand that most large organizations, and this is kind of what it's targeted at, and I have a lot of experience in that space, they don't want to necessarily do that. They want to have a trusted third party that they can use to secure their networks. Why do people use AWS? Why do people use Google Cloud? Why do people use MS Office? All those sorts of things. So I appreciate a lot of you guys who are watching this from the home lab space. You probably will spin up a VPN, and there's nothing wrong with that. But this product isn't necessarily tailored for you. There are tons of organizations out there that want the simplicity and the power of what Twingate are offering. And you need to remember that you don't have all of your eggs in one basket. You have a different authentication provider, as well as potentially a different identity provider. You can also have a number of integrations to bolster your security through EDR solutions such as CrowdStrike, and also then notifications that would go into, say, your security incident and event monitoring tool. As always with anything like this, it's going to come down to a risk-based decision. It's going to tout the convenience of using a solution like Twingate against the risk, complexity, and time and money of doing everything yourself. The whole design ethos is to access resources anywhere securely. So if you've got a remote workforce, for example, this could be the perfect solution to allow your workers to access the services that they need securely. Again, there's no need to expose any of this stuff to the internet. You can manage this all securely through your Twingate solution. So before we dive into the configuration, let's have a quick look at the architecture. This will be useful as we talk about lots of different things down the line, specifically things like the client, which is over here, the relays, the controllers, and also the authentication. So as you can see on here, we've basically got the client over here on the left. We've got an environment over here on the right. You can see that the client connects to a connector. Now the connector is what exposes all of your resources. You can see those over here. And we control what the connector can see by creating a network. We'll be doing that in a moment through the UI. That basically creates a NAT traversal. But first we need this relay. So essentially the client talks to the relay and the connector talks to the relay. And this is outside of your network. And what that does is basically exchange some tokens and facilitates the information necessary to create and traverse that NAT. So that's why you don't need any ports forwarded for this. Basically, it's reaching out, it knows it's reachable here, and this one is here. If you hover over this, and I do recommend you go and read it, it will tell you more about the details about how that magic works. Now, one important thing here as well is you'll notice down here we've got the identity access provider. What you can actually see here is with the controller itself, you can see this authentication flow. So whilst it isn't self-hosted, actually Twingate don't have your account details. So your account isn't with Twingate, you need to authenticate with your identity provider, which again starts to reintroduce some of that independence, some of that privacy, and some of that security. If everything was hosted through Twingate, it could well be a single point of failure, but that isn't the case, and it's been specifically engineered that way. So in a nutshell, what this allows to happen is peer-to-peer connections between your client over here and the resources that you're wanting to access. What that means is it's fast, it's responsive, and equally the changes you make within the administrative console are really fast as well. And probably the best thing about this is that you can try it for free before you sign up. So let's dive right in now and let's get this up and running. So to sign up, you're going to need an email address, and it's going to ask you how do you plan to use this. I'm using this at home, so that's the demonstration I'm going to show in this video. But if you're obviously a work enterprise, you'll probably get ported towards a more enterprise solution with their various support channels. So we're going to get started, and if you have an existing network, you could also sign in down here. So once we click get started, what is our use case? So, clues in the title for me, this is going to be a home lab. Once you've selected your environment, we want to hit continue. And now we're on to creating our network. So your network is basically how you're going to log into this. This is your own private space. We'll get onto what a resource and a connector is soon, but first you need to come up with a network name. So I'm just going to call my Jim's Garage Demos, and that's going to give me the full network name, the network URL of jimsgaragedemos.twingate.com. So if we click here now, it will take us to our network, but before that we need to sign in with an identity provider. Now you can use a different identity provider down here, and you'll be able to do that later on. So if you're using, say for example, Okta, you would be able to choose that and integrate it with your existing solution. Probably something, if you're already an enterprise, you'll likely have that set up. Now, as you can see, mine was just a simple Gmail account. So I'm going to sign up with Google. Now, I'm going to specify the same email address I put when I signed up. We need to accept the privacy notice around what it's going to share. And then it's now off and building our network. So within about 30 seconds, you can see that we've created it and we're already into the dashboard. So here we get onto the notion of resources, networks, and downloading Twingate. So to get this up and running, what we actually first need to do is to define the network, which you can see sort of behind this pop-up. We're then going to add a resource. Now a resource can be basically anything. It could be a web server, it could be a machine, whatever it might be. And we want to make sure that our resources are in our networks so that we can expose them later on. Now, you can have multiple different subnets, you can have multiple different resources, and they're all controlled via connectors. We'll come on to that later. Then we're going to need to download the actual clients, and the good thing is here there's basically client support for pretty much anything. You've got Windows, you've got Mac, you've got Linux, and you've got containers. So you can spin this up in clustered environments like Docker, Docker Swarm, or Kubernetes, for example. You could stick this up in AWS or any of the big three cloud providers, or you could put this on physical machines, VMs, you name it, it does it. So we're going to start the setup process. So the first thing we need to do is to basically add a first resource. We can obviously skip this as well if we want to and you're more established, but we're going to set this up first. So I'm going to put in a CIDR range, and I'm going to put in my local IP range. So that will be something like 192.168/16. That will give it access basically to all of my machines. Now that's definitely overly permissive, especially if you're going to set this up in an enterprise setting. You'll want to dial that down, but we can also restrict that later on when we get down to user profiles, and we can give granular control to specific applications to specific users. So I'm going to choose the entire subnet. But what is great about this is you can choose an entire domain, you can choose a specific IP address, and you could also use a fully qualified domain name. So what's the subnet address I'm going to put in? I'm just going to put in 192.168.0.0/16. So now we're going to create that resource, and now that's successfully created, it's going to go on to connecting the network. Now that we've completed the network, we get to choose our deployment method. And as I mentioned, this is naturally designed to be plugged in some of the largest cloud providers like AWS. But we can also do script-based deployments as well. And Terraform is one of the key areas that it's excelling in. But for this example, I'm going to use Docker. So I'm going to deploy the Docker containers, which will be the connectors. And the way that connectors work is we've defined our network. That's the IP range of our internal resources. We will define a resource itself, and then we'll establish a connector to that. And then the connectors are basically you connect to a connector. We'll show that in the app later. That connector has access to the resource which sits in its subnet, and thus you're able to access it. And I also mentioned that in the admin console, we'll be able to assign specific users to use those resources as well for an extra level of control, really building up that notion of zero trust. So have a look at the different script-based deployments that you can use. So for Linux, for example, you can just basically install the binary files, but I'm going to choose Docker. And here is the requirements basically for the deployment. We want to deploy this close within our network to improve the network performance, i.e. latency. And we need to now generate some tokens. So I'm going to click generate tokens, and these are the tokens that are going to be used for the connectors so that it can authenticate back with our Twingate account. When I click generate token, it's going to ask me to authenticate again, which is a good security step. I've clicked on the same email address, I'll click continue, and then that should generate some keys. Scrolling down, you can see now that we've got the access keys that we require. Now that we've got the tokens, we can actually scroll down to the third set of options, which is to customize the Docker command that we're going to use. So you can put in custom DNS servers, albeit by default it's going to use the ones that are on your local network anyway. So in this case it's going to use my Pi-hole, for example, but if you wanted to specify your own DNS resolver, especially if you're more sort of a business setup, you can obviously do that. You can make the connector available on the local network itself, so that will basically expose a port on the container if you wanted to do that. And you can also log local connections to that container if you enable it. So looking down now, we can actually see the command that we need to run. So it's as simple as just copying this command, then heading over into your Docker machine and spinning up this container. When this container deploys, it will automatically, because of those keys, connect to your account, and you should start to see that in the admin console popping up. We'll see that in a moment. So I basically now copied this command here. I'm going to head over now onto my Docker host and I'm going to deploy this. So here you can see a fairly typical setup for a Portainer in a home lab. I've got some random services running here, but crucially there's nothing at the moment for Twingate. So if we now hop into the terminal on this machine, we'll be able to deploy that container. So now connecting to this Docker host, if I paste in the command that we took from the website, we're going to do that Docker run. It's going to use all of the variables and the configuration settings that we specified on the website. When I hit return, it should go away, pull down the necessary containers and spin it up. So now it says it's completed. So if we hop back over into Portainer, hopefully we should see that coming up. So here we see the container spun up, that connector. If we have a look in the logs, you can see that it's offline, it's authenticated, and now it's online. So hopefully, if we head back now into the official website, we should see that that's now connected. So now we've got a nice green tick, connect to your network. Congratulations, you deployed a connector. So now we are ready to move on to the next step. So if we click continue, we now need to basically download a client. So think of it this way. We've specified a resource, which is my internal network. We've created a connector, which connects into my internal network and then exposes access because I put a 00/16. Basically, it can access anything in that subnet range. What we need to do now is actually to download a client to connect using our Twingate credentials and then access those services. So again, there's a myriad of options here. We can download it for Windows, Mac, Linux, Chrome OS, iOS, and Android. I'm going to do a Windows and I'm going to do a mobile, in my case Android, because I think that's probably going to be the most popular use case and the others don't really differ other than the installation methods. Once we've got this downloaded, we should now be able to connect to our Twingate account and access some of those resources. So let me start by downloading for Windows, and then I'll get onto the Android setup as well and I'll share that on screen. So with that downloaded, it's a simple case of running through the installation process. That shouldn't take too long, and once it's finished, you'll have something in the system tray and you'll be asked to log into your account. We're going to be using exactly the same credentials as we've used throughout the video, and that should then be able to list the connector that we established earlier. You may need to reboot your machine after that. So on Windows, I'm going to go ahead and do that, and I'll see you in a moment. So after rebooting, it's going to finish the installation process. So we're going to hit continue. And now we're going to need the URL. So that's this one here, this jimsgaragedemos.twingate.com. So clicking that copies it for us, and then we just need to paste that into here. So if we click join network, it should now ask us to authenticate again. Thankfully the browser pops open and we just need to sign in again with that same account. Hitting continue on that account should now go back to the application. We've authenticated, and hopefully that app should now join the network. That disappeared, so that means if we go down to the system tray, we should see Twingate now connected. So now with that completed and the application available in the system tray, we should be able to go back here now and we can see that we've set up complete. Now we basically have all of the building blocks in place. The next thing would obviously be to add a number of users. You could then add more resources if you wanted to, and enable some DNS filtering as well as a myriad of other features that we'll have a look at later in the video. So let's go to the admin console. And here you can see basically the control hub for your Twingate network. You can see on the left we've got the network, which is where we are. We can manage our team. We can specify the devices we want to be able to connect. You can even do things like ban all Android devices or ban devices that haven't got a certain serial number. Loads of cool stuff. There's different policies that will govern the actual access control. There's internet security for people who are on the network. And then some generic settings around sort of your account and network itself. So if we remind ourselves of what we've got on here, we've got the resources, which is that network, my first network, that we created during the process. We've also got the remote networks. That's where we've deployed the connector. And we've also got the actual connector itself. Now by default, it only sets up a single connector, but you can also set up a separate one, which will act as kind of a failover. So if we go to the remote network, you can see here one of two connectors, and we click on that, we can actually create a resource. So this one here, this tireless rabbit, it generates a random name. You can obviously choose your own. We can click on that, and then again, we can click this, and then we can actually go down, we can generate some new tokens. Once we've got those tokens, we can then go and deploy this again. So exactly the same process. I'm going to copy this command. I'll head over into my terminal, and I'll paste that in. With that pasted in and deployed, we should now see again now back on the admin page, we should see that this is now up to date and it's connected. So now we've got the actual controller and we've also got the relay. So now that we've got the recommended connectors set up and we can see those live on here, why don't we test this out? Now I'm going to make this a little bit more interesting and I'm going to move over onto my Android mobile. That's because I can quite easily consider that to be a mobile device, i.e. it's not the machine I'm recording this video on, which is on my local network. I want to do a true test of accessing something through Twingate that I've exposed using one of the connectors. So after downloading the Android application, we want to connect now to our network. So if you remember in mine, that's the jimsgaragedemos.twingate.com. And now if we hit join network, it should ask us to authenticate. Again, I'm going to use my Google account. And here you can see that we are now connected and you can see the network we defined earlier. So I'm going to knock myself now off the Wi-Fi and I'm going to try to connect to one of my local services. So if I go to the IP address of one of my local services, something like Pi-hole, you can see that I'm connected to the VPN in the top. And this is an internal IP address, so I would only be able to access this if Twingate was working. You can see now that I've got to the login page, which is excellent. And that's specifically because we have that rule in place whereby we specified an IP range, and that's what's letting us access this website. And I can basically change that to anything I want on my network, so something like Plex for example. But that's not really very friendly. So let's try and fix that. So back in the resources tab, you can see this one we created earlier, which is what was enabling me to access both the Pi-hole and the Plex via the IP. And hovering over that, and this is important as well later on for security and principle of least privilege, etc. You can see here the default policies and the protocols, and you can be discreet in defining which of those you want. So for this to work, let's create a new resource. And this time we're going to call it Pi-hole. And we're going to make sure it's on this network here because you can assign this to different networks. On the address, instead of a domain name or CIDR, we're going to put it as a browser address. And that gives the sort of handy pop-up as well in the tray to open this within the browser. So if I put a browser address, I'm going to call this one piehole.jimsgarage.co.uk. Now, interestingly as well, you can put in here, say, wildcard addresses. So I could just put *jimsgarage.co.uk and call this one just all DNS or whatever. And that would allow me to access anything that's on the Jim's Garage DNS through this network. So we can also create a secondary address for this. So that's called an alias. Now, what an alias would do is basically if this DNS record didn't actually exist, remember what's happening here. We've actually got a split tunnel going on. So when I'm on my client on my phone, it's basically matching anything. So it has its own basically access control list on the phone. And it says that look for things like piehole.jimsgarage. So if I create this resource, you can see now that anyone can access this address here. And it's on all ports, etc. But what's happening is there's actually now, say, a file stored on my device within the application that says whenever you try to access this, don't go out to an external DNS provider. Go to the DNS provider that's on the Twingate, i.e. the connector. Remember what I said earlier about the connector using local DNS. So it's going to say on my phone, hey Twingate, you want to send this to the connector that's in my network, and then the connector is going to query my DNS provider, my Pi-hole, and it's going to resolve to itself in this case. So we should now be able to hop onto the phone and check that this works. Whilst we're looking at this, it may be worthwhile just clicking onto here and looking at some of the other options that we've got. So we can actually edit this as well. So let's go to the ports. Now in here, if this was just say a specific server, so technically we only need to allow TCP ports on this one, and I could say we just want to go to port 443 or port 80 depending on what your traffic is. Obviously as well, you could allow it to just be UDP traffic, and you could block things like pings. This is really powerful, and it's especially important if you're not an admin, i.e. you've got different sets of users. You probably want to give them different levels of access to different services. For example, if this was your NAS, maybe you don't want to allow them to have administrative access to the console, so you might block the web interface, block SSH, etc. But you would allow them to connect, say, an SMB share, and you'd put in the relevant ports and protocols to enable that. So it's really powerful and very prescriptive. So now that we've got that rule in place, let me hop back onto the phone now and let's see if we can access piehole.jimsgarage.co.uk. It should show the exact same interface as before, but this time we're using the DNS record and we're not using an IP. So now on my phone, what you can see is we've got that new resource added in Twingate. We've got the original IP and we've now got Pi-hole. And rather handily, what you can actually do is just click Pi-hole and then you can say open in the browser. So let's see what happens. We get to the actual interface for Pi-hole and it's using HTTPS, all of which is being routed over cellular via Twingate. Perfect. So now we've demonstrated how to create a network, how to create some resources, and how to pin some connectors to that so that we can access it. And basically these are the baby steps that you need to replicate now over and over for all of your different users and all of your different environments. It really is that simple and it really is that quick to use. So let's now have a look through the rest of the admin console and see what else we can do. So in an ideal world, you're probably going to have lots of different resources, tens, hundreds maybe. You're going to have lots of different remote networks. So at the moment, this is only my home lab. But what if I had, say, a friend's home lab? What if I had, say, a co-location? What if you're a business, you've got multiple offices, you've got multiple data centers, you've got multiple cloud environments? What you would do is basically for each of those, you would create remote networks. And in each of those remote networks, you would create a set of connectors. And then those resources would be assigned to those remote networks. And then we get on to the next bit, which is really the bit where it excels. We know that from resources, we can assign all the different ports, but you can see at the bottom here, this everything access. That's the next bit that we need to look at. So if we head over to team, you can see that I've only got one user here. But imagine tying this into your identity provider or scaling this up to your entire business. You would have tens, hundreds, possibly thousands of users in here. And what's good with that is from an admin perspective, you can put those people into groups. So for example, the everyone is a default. You could have something like front office, back office, IT, admins, all of those sorts of things. And so you would create the number of groups you need, you would drop the people into the groups, and then groups would be assigned to different resources. And that gives you that granular control, that principle of least privilege. You only give the people access to the resources they need for their job. Then we get on to services, and services is where Twingate shines when it comes to things like your CI/CD pipeline. So as I mentioned at the start and we saw on their website, things like Terraform, for example. What we need to do with a service is basically create a resource and create a service key, and then we can do things automatically, well, through automation. So you could actually build out your whole infrastructure as code with something like Terraform, and as part of that deployment you could do a whole load of things like creating different connectors, different networks, different resources, and basically automate your entire Twingate network. That's pretty powerful. And you might be thinking that's it, but no, we also have the notion of devices. So as you can see here, I've got my Android phone, which I use in the demonstration, and I've got my Windows machine as well, which is what I'm recording this video on. Now, that wouldn't be enough for Twingate, so what you can actually do is start to drill that down. And we'll come onto that in a little bit when we get onto some of the policies, etc. Now, immediately what you could do from this interface, for example, is if you don't like the look of something on here or you want to instantly revoke access, you can hit this here, you can tell it to verify the device, you can tell it to archive it, or you can immediately block the device. Also, from a bit like a NAC, a network access control, you can actually add a list of serial numbers in here, a bit like you might do with MAC addresses, for example. The idea here is that if the device serial doesn't match the one that you've got registered, it won't allow it on the network. And you can think of that as useful for, say, if somebody's credentials were stolen and somebody tried to access it on a different device. They'd need both parts of the puzzle. Bit like multi-factor, they'd actually need the device and they'd need those credentials. If we head into the policies, this is where it gets pretty in-depth again. So it comes with the default policy, which basically allows anybody, and you'd obviously want to override that if you were doing this in an enterprise setup. If we have a look down here on the bottom left, you can see authentication. So we can specify the re-authentication frequency. Now I believe that's set to 1 hour initially, so you could drop that down or you could increase it. You'd probably increase it. Most people would get pretty aggravated if they had to log out every hour. But what you could actually do is change that for different people. So you could have your admins automatically re-authenticate every half an hour, but maybe your front office staff, who knows, every 24 hours, that might be right for you. We also have the notion of two-factor authentication, which, as everybody knows now, is pretty much a default for any service that we use. You can also go down to the level of blocking devices based upon their operating system, and not even just the operating system itself, actually whether they're verified and the technical configuration of that device. So we could say we only want Windows machines, but they also have to have, say, drive encryption enabled. Or we don't want Windows machines, we just want Mac, but it has to have encryption enabled. All of those sorts of things. We can also do some geo-blocking, although that's blocked behind a paywall at the moment. So as I mentioned before, improving that user experience is key, and that's where we can do it within the sign-in policy. And you can see here a number of options which change that default behavior. So on the left, the whole idea of this is to minimize the hassle to the user. So things like making sure you meet the approved OS requirement, authenticating every 30 days, and MFA is not required. All of these are manageable, and actually if we take that a step further, we can go into some device profiles. So here you start to see what I mentioned earlier. So the approved operating systems could be these 5 here, but say for example we know that we don't have any iOS users, so we can just block those. So anybody, even if they had legitimate credentials, couldn't access it on an iOS device. We can also then be quite explicit in terms of we need to say that HD encryption is on, we want biometrics enabled, and we want a screen lock, so we confirm changes. That means now that Macs are allowed, but only if they satisfy these requirements, which is pretty awesome. You can also create some more custom ones here as well if you wanted to. The penultimate setting really is the secure DNS. Now, by default, I mentioned those connectors, they're going to use your local network connection. So they're going to use the DNS provider on my network, so that pie hole that we just saw accessed, but we can turn on enable secure DNS so that anyone who connects to this will actually be using DNS over HTTPS, so that's kind of got some built-in filtering. After that, we can actually do some client configuration as well, such that even if a device is not using the Twingate connection, it will still use, and it will be signed through a machine key, it will still be using that secure DNS setting. Lastly, we get onto the settings, and these are more sort of general account settings, i.e. this Twingate network that we set up. So you can enable MFA here, for example, but the key things really are this identity provider, which we touched on earlier. So here you would connect it to an identity provider. So say your business used Okta, for example, you would connect it to Okta, and that should pull down basically all of your users. So you don't have to put it through here. You want to leverage something that's designed for that specific purpose, something like Okta. What's great to see as well is this device integrations, and as someone who works in security, making sure that your network, i.e. this is basically the whole purpose of this, is to secure your network and only give access to people you trust, but they might have stuff on their machines that you don't necessarily trust or could indeed be malicious. So it supports a number of industry leading tools here, for example something like CrowdStrike, and we could connect this into an EDR solution. That's pretty powerful if we combine it with some of the logging that we saw earlier, so we've got kind of real-time detection across the network itself. By default, email notifications are set up, and I've been playing with this. I'll basically get an email if something goes down, i.e. a connector goes down. You can also set up some webhooks for some API crawling, so if you're going to create your own application, maybe you can do some health checks, etc., or maybe even control parts of the network through the API itself. You can produce audit logs of your network and sync those up to something like an S3 bucket in AWS, which is really handy. And lastly, we've got the API as well, which is an authenticated API. So here you would generate the tokens necessary to exploit that API. So thank you for watching, everybody. Let me know what you think about Twingate down below. I think it's a great way to restrict access within your network to only the individuals you want to have access to those resources. The fine-grained granular controls and that zero trust model gives you the full power and confidence that your applications are going to remain restricted. Being able to lock it to specific devices, even down to the operating system level, is amazing. And the fact that you can do all of that just through a simple admin window is awesome. So let me know if this is something that you're going to use, or if it's something that you've already been using for a while, and what your experiences are. Anyway, if you've liked this video, give it a thumbs up, hit that subscribe, and I'll see you on the next one. Take care, everybody.